these guys are going to be sequences with a common difference. So what happens here is that we're talking about common differences in the sequence. Really simple idea. If I think of this as, oh, I don't know, -3, 1, 5, 9, 13. So what is the common difference? Is it +4 or -4? +4. So what happens here is we do this. When we're talking about this arithmetic sequence, we're looking at what the first term is and what the common difference is. So we label stuff out. We have the first term is -3. Our common difference between everything is 4. So what happens is that we can write out a generic rule for this. And this is one of those formulas that I told you that we're going to have. I will give you, but you'll have to know how to use it. Okay? I'm not going to tell you which one is which, if that makes sense. Excuse me. What happens here is we get this, to write this in terms of a sub n, our nth term, or our nth rule, if you will, is always going to be your first term plus n minus 1 times common difference. And that's going to be the generic rule for writing these formulas out. So let's see, let me write this off here too. And this is going to be extremely helpful when you know that how to find the equations of things, especially if it has a common difference between the two. This works if it's adding 4, 2/3, -7/2, whatever. As long as the difference between the two values is always the same, this is the formula you use. Easiest way to tell whether or not your differences are the same is just look at between each term. It would have, but not every one of them was an arithmetic sequence. Some of them were geometric, some of them were neither. There was no common difference. We're not there yet. We'll do geometric next week, but geometric can have a common ratios. Okay. So in this equation here, if I have to write out the nth rule, my nth rule means that it would be my first term, -3, plus n minus 1 times my difference of 4. Distribute through, -3, 4n minus 4, which means my nth rule is 4n minus 7. Go on your merry way. That's your answer. If your first term is going to be -3, that means n is 1. So 4 times 1 is? Minus 7 is? -3. And so on and so on. Again, there is this crazy machine that you guys have relatively close to you. And if you're not colorblind, it's probably yellow. Unless yours is green. Which means there's a button on the calculator. Your pencil bag matches your shirt. If you hold it too close, you won't know which is which. Squirrel! So, it's 2 of us. Not me and me, but just me. Anyway, there's this y equals button in your calculator that you can you can always verify. Just make sure that you're correct within your table, because you can check n equals 1, 2, and so on. Okay. Is this arithmetic? No. Why? Could you write the rule if you had to? Yeah, probably could, but I don't want to. Which means we can do a bunch of algebra. Yay! The 20th term. Yeah, so what we want to do, a lot of these will have two parts to it. They'll ask you to write the rule for the nth term, and then find, in this case, I'm going to ask you to find the 20th term. So what we do here is we have to figure out the rule. Once we figure out the rule, then we just substitute in 20 for n. So if my sequence is going 50, 44, 38, 32, first thing we have to figure out is what's the first term? All right. The common difference here is, very good, remember it's going to be -6, which means my rule, my nth term is first term plus n minus 1 times my difference. So it's 50 plus n minus 1 times -6. So I get -6n. This becomes +6 plus 56. That's my rule. You okay with that? I will also remind you that you'll probably screw up with a negative once or twice. So be careful. Always go back to your calculator real quick and just double check that that formula generates those terms in the sequence. If it does, you did it fine. If not, you screwed up. What do you mean? Are you writing this 56 minus n? Or 6n? That's fine. It's more common to put it in that slope-intercept form. Just it's what normal people do. So that just means that the 20th term will be -6 times 20 plus 56. That's what, -120, add 56 to that. What is it? 64? -64. Once again, should you ever get any of these style questions wrong? Because there's a calculator always to verify your stuff. Are you almost willing to say that, okay, I could buy this, but for right now, all right, I can take that. I can deal with that. Yes, and I will. All right, let's try a different version of it. Remember, if you start to think about the idea of what this formula looks like, a sub n, first term plus n minus 1 times common difference. How many different variables are there? There's really only 3. There's really only 3 differences here because the value of the nth term, that value of n is in 2 spots. So you have to figure out your first term, common difference, and n. So if you've got 2 out of the 3, you'll always be able to find the third. It's just a matter of working with an equation. So in this case here, it says that the 13th term in a sequence is 30, and the common difference is 3/2. Write the rule, which means if you've got your nth term, you've got your difference, what do you have to solve for in this case? The first term. You got to find the first term and then just rewrite. So if I know that my 13th term is 30, that means then that 30 equals first term plus 30 minus 1 times 3/2. Oh, it should be 30. This is this is, I'm sorry, this is 30. This should be 13 here because this is the 13th. This is the n is the 13th. Sorry. I went the 13th term is 30 and then I got ahead of myself to the other one. Yeah, because they were not going to, I mean, you'll get a fraction here now, but that would have been 29 times 3 over 2. Okay. So, real tough, 13 minus 2. Minus 1. I was looking at the 2 when I said it. Yes, I'm fine. I was just seeing if you were paying attention. Very good. You guys are doing great. Keep it up. So 13 minus 1. That's it. I've had it with you. right, what's 12 divided by 2?
7.
6. All right, 6 times 3.
21.
Which makes your first term. So what we're doing here, guys, is we're working backwards to solve through to get the first term. Once we get that first term, then we can rewrite and go from there. So let's see here. That gives us. Yeah, because it was right off the rule. So that gives me 12 plus 3 halves and minus 3 halves. This is a really easy fraction to work with because it's just halves. So when I have 12, I can say that's the same thing as 24 halves. So 24 halves subtract 3 halves gives me 21 halves. So my final answer would be a sub n is 3 halves n plus 21 halves. And once again, it'd be very, very easy for you to check your work by putting that equation into your y equals, go to the table, and see if the 13th term actually is in fact. Well, when you have common difference, you won't have common difference as an exponent. But, correct. It's addition. You will have exponent stuff when we get to geometric. It is actually very simple to work because when you work with exponents, you work with logarithms, and a lot of this stuff will work out super clean because if you start looking at the numbers that we have here, it's going to be clean numbers to work with. So we'll get to that probably. I think we get to that Monday. And it's pretty easy. Do you need to do another one of these? No. Okay. All right, let's make this a little more difficult. There's A's, not Y's right now. There's a Y equals button that we can use later. So 2 terms in an arithmetic sequence are the 6th term is 10 and the 21st term is 55. Which means I want to write out a rule for the nth term. Yes, sir. Arithmetic means it's a sequence that has a common difference. It's going up or down by the same number every time. So add 3, add 3, add 3, add 3, or subtract 7 halves, subtract 7 halves, subtract 7. That's all that means. Geometric will be a common rate, which means there's either multiplying or dividing. So we've got 2 terms. We've got the 6th term is 10, the 21st term is 55. Now, when we see stuff like this, here's a little bit of a hint. You're going to have to create a system of equations. Now, when it gets to that, it winds up being a very quick elimination step that occurs after things get simplified the first time. Let me show you what happens here. When we're using the rule, the nth term is your first term plus n minus 1 times the common difference. As we go through this, we know that the 6th term is 10, so that has to equal the first term plus 10 minus 1 times some common difference. Damn it, I did it again. Sorry, I did that twice now. And then I have the 21st term. Well, I remembered this time. when you simplify that, you wind up with a very quick system. I have 10 equals first term plus 5d, and 55 is first term plus 20. What method is this trying to get you to set up to be able to solve for? Or let me ask you this, what is this trying to get you to solve for first? D. The reason why it's trying to get me to solve for my common difference first, because if you notice, your first term is the same in both of them. So this is the case that I can use, remember this elimination, where you just subtract one from the other to get rid of it? So what I would do is, since the 55 part is larger than the other one, I would just rewrite this equation here. Yeah. And subtract all parts. Oh, yeah. There. And I'm going to erase all the part, not erase it. Line it back up there. So what's 55 minus 10? A's go away, and then we have 15. So what's your common difference? You now have your common difference, and you now also have the answer. What did you do to solve for the original? Substitute back in. So if I take and I substitute back up here, I get 10 will equal first term plus 5 times 3, which gives you your first term at -5. So again, it's not that it's any crazy amount of work. It's just taking a couple bits of algebra that you all know how to do together. Now, will there be problems like this that you could probably figure out the common difference in your head? Absolutely. You might be able to tell the differences there. Do you have to do all this work then? No. I would still go back and verify that it works. So my first term is -5. So my rule would be a sub n first term n minus 1 and times 3. So I get 3n minus 8. That's been happening for a long time. Back in my day, we used Grecian formula for men. Anyway. Hey, guess what? There's this thing called a sum. Oh, just put it in your kit. Find the sum of the first n terms of an arithmetic series. Again, this is a formula, straight formula stuff. I'm not going to tell you which is which, but you'll be able to tell real quick the difference between S sub n versus A sub n. What do you think S stands for? Sum. All right. Now, when you're looking at a formula sheet, you're going to see the fact that you'll have first term plus the nth term all over 2. So that might be a dead giveaway that there's an addition of an arithmetic one versus geometric when we get to it next week. It's going to be really easy to tell the difference. I don't make you memorize these. You just have to know which one's which. Okay. So this means that the sum of so many terms in a sequence is going to be that number of terms in the sequence times the quantity of first term plus the last term divided by 2 times however many they were. Okay. Again, it's going to be a matter of you'll have to write out the rule for the nth term sometimes and do some substitutions. Okay. Excuse me. So let's consider, I love how they say this, consider the arithmetic series. And consider. Next, find the sum of the first 30 terms. Okay. And find the value of n such that S sub n equals 175. That means there's two parts to this question. The first part is relatively simple. Rephrase this as just like you would say. The first thing you do is write your name. Well, now we've considered it. Do you guys have big wheels? Or tricycles? My kid has one of those giant, the green machine big wheels with the. No, the big wheels, the big green machines where you've got this and you've got the big wheel up front, pedal, and it's got the big sticks. Drive it in the, the seat. No, they don't have one as the spin outs. So you guys know the Canadays, right? So we used to live next door to the Canadays, and when Brandon, the oldest one, he's like junior in college now, maybe. Unless I'm old. Yeah, he's old. But they had one of those ones with like bike tires on it, with like an emergency brake, so you can do donuts as you get going real fast. And it had like a regular bike's gearing, so like regular big wheels, you just keep pedaling until your legs fall off. This had gears, so you can stop pedaling for a while and coast. So you could get going real fast and just hit the thing and go, my Lord, that thing was awesome. All right, I'm really like 12 years old, in case you guys haven't quite figured that out yet. I love stupid stuff. But yeah, the big green machine, my kid has one, it's just awesome. I had one as a kid. Now one of my neighbors, this is pretty cool too. One of my neighbors, his son got a hand-me-down Power Wheel, like how we had one that your brother did for me. But he did one for his kid that he put two 24-volt Power Wheel batteries in is it parallel or whichever one just doubles the power. So yeah, whatever that is. So he put them in sequence there. So like his kid's Power Wheel is now like 48 volt. The thing just does wheel spins, and it goes. So he's driving around. This little guy, he's 3.5 years old. He's like this tall, and he weighs like 20 pounds, if lucky. So he's like flying around. He turns the wheel and just power slides around corners and just does donuts. The smiles on these kids' faces as they're in these things, it's awesome. So my neighborhood is a bunch of people driving around like a bunch of idiots on big wheels and Power Wheels. Awesome. So I have an old motorcycle helmet that I don't use because they get bad after a while. So I put this big giant helmet on this little kid in this Power Wheels truck. It's got this mirrored screen out there, and you can see he's driving, sliding around. More power. Anyway, so find the sum of the first 30 terms. So sum of 30 is going to be the formula. Not happening. That's why I have it written down. I don't know if you've noticed things that I need to reuse. I write on boards so I can look back and reference. That's good. I like that. So what this is asking me to do is that I have to find the sum of 30 of them, which means my n value is 30. I know what my first term is, but I don't know what my 30th term is. So with this style problem, and when we get to geometric, no matter what, you're going to want to write out the formula for the nth term, okay? Because you're going to have to reuse it again later. So first thing I'm going to do before I get into all of this is I'm going to write the rule for the nth term. Okay. My first term is 4. My common difference is 3. You okay with that? So I have 4 plus n minus 1 times 3. So this becomes 3n plus 1. I'll be okay with that. The reason that I wanted to do that is because I need to figure out what the nth term is. I have to figure out what the 30th term is. So the 30th term will be 3 times 30 plus 1, otherwise known as 1. Sorry, it looks like a. So the sum of 30 of them is going to be 30 times the quantity, 4 plus, what was it, 91, all over 2. You okay with that? So 4 plus 91 is? 95 times 15 is? Gotcha, it ends in a 5. 1425? Okay. Not terrible? Now the other part of the problem was find the value of n such that the sum of so many of them adds up to equal 175. So let's figure out how do we get that to equal 175. Now let me split this into 2 here. So I know that I have to find the sum . 175 of them. Do I know how many add up to equal 175? Nope. Do I know what the first term is? Yeah. It was 4. I don't know what that nth term is, but do I know what the equation for the nth term is? Bless you. That's the reason why I always have to write that out, so that way I know, because these types of problems always going to come in 2 parts. Find the sum of them, find out how many you have to add up to equal. So you're always going to want, gentlemen, you're always going to want to write out that rule for the nth term here, because you're going to reuse it. So I put that in as 4 plus 3n plus 1 all over 2. First thing I'm going to do is get rid of that divide by 2. How do I do that? All right, so if I double 175, I get what? 350. So then I get 3n plus 5. So I have n times 3n plus 5. What times what is negative 7, 1,000 something number I don't want to do that adds together equal 5. But hey, I bet you there's an easier way to do that. I bet you're right, Mackie. Oh yeah. Or are you going to take it away from it? No, not for stuff like this. That's just me. I know. Is everybody? This I will. Does everybody see why I moved that 350 over? Here's the question. As I'm going through this, remember what's happening. I'm trying to figure out what value of x. One's going to be a plus, one's going to be a minus for this. When I set it equal to 0, I need to figure out a positive 0 here, don't I? What gives me a positive 0? 10. Okay. Will it always be that clean where it's going to be 10? Could it be 10 halves? Now, that's the thing. What's going to happen here is that you're going to be able to use your calculator to kind of search around to see where it occurs. I see that it's happening at 10, so I know that n's got to equal 10 for this case. All right, I can always throw 10 into the equation to see if that gives me the correct answer. But if this does happen to land on a halvesy, if you look at, do you guys remember how to use the graph to calculate a zero? You guys remember how to calculate zeros on the graph? Correct. We graphed in terms of pi, remember? Yeah. And I can just use calculate zero and just go through there. In case it does wind up a halvesy. But remember, can you get halvesy for the number of terms in a sequence though? No. It has to be an integer, so it should always show up. Okay, so that was just a cool thing. Yeah. I will give you homework. Yeah, these should be easy. All right. Yeah, these the in here the first three of them are yes or no. The last three of these I think are also just press a button on the calculator. They should not be different. They should not be different. Carter, will you check and verify that the PDF opens? Because I'd hate for either you or somebody that sits relatively close to you to have to send me an email or get a snarky email. Bless you. I believe you could probably knock it out today if you want to do it flex. What's that? Candle. Yeah, here's Mr. Starkey in his emails. He's trying to sound like, lawyerish. He's not even paying attention. I told Seb right away because I was in there with Seb. He's like, yeah, that doesn't surprise me. Is that Captain America or Team America? Oh. Too busy. I got things. Don't know how the YouTube works.